Hello, my dear student. In this video, I will give some insights about the Jacobians. Okay, so please check the heading. The heading is Jacobian. Okay, now try to understand. The first you try to understand the definition. Please write down if u x comma y and v x comma y are differentiable differentiable function of two independent independent variables x and y, then the determinant this one del u del x del u del y del v del x del v del y is called the Jacobian Jacobian of u and v with respect to respect to x and y respectively. Okay, and it is denoted as j u v by x and y is equals to basically what you have del u del x del u del y del v del x del v del y. The another notation you have basically del of u comma v del of x comma y. Okay, so this is the basic notation. Okay, clear? Is it okay? Okay, so this is the basic formula of Jacobians. So basically this Jacobian can be in terms of three variable also. If it is a three variable, in that case your determinant will be, suppose if your u, suppose u is a function of, if u is a function of x y z, v is a function of x y z, and w, three variable will be there. That is u v w, basically both all three are function of x y and z. So in that case the Jacobian will be del u del x del u del y del u del z del v del x del v del y del v del z. Okay, and del w del x del w del y del w del z. Okay, clear? The three order, third order determinant. Clear? In case of triple variable. Now I'm going to solve some question based on this process. Now the question is very interesting. If x equals to u e to the power u cos v and y is equals to e to the power u sin v, then find this. Okay, so first you write down how to solve it. It's very easy, very simple. So please write down here x equals to e to the power u cos v and y is equals to e to the power u sin v. Okay, so first try to understand what is our next requirement. Our next requirement to this, so therefore, so del xy by del uv is equals to determinant del u del x, sorry, it will be the for main function is xy, then independent variable is uv. So here you may write del x del u del x del v del y del u del y by del v. So these are the four unknown. So first you need to calculate separately. So del x by del u. So from here e to the power u derivative is same. So e to the power u cos v. So del x by del v. What is the cos derivative? Minus sine. So it will be e to the power minus u sine v. Okay, same way del y by del u. Del y u is equals to e to the power u sine v. Del y by del v is equals to e to the power u cos v. All four are known to you. Just substituting the determinant. So del x del u, it is coming e to the power u cos v del x del v minus e to the power, oh something is wrong here, it should be like v only, huh? u. So e to the power u sin v e to the power del y del u e to the power u sin v e to the power u cos v. Okay, now you need to simplify. Already you know the determinant, this into this minus this into this. So ultimately it is coming. So if I can move to the second, now it is clear that now we need to simplify further. So ultimately it is coming this into this, that is e to the power u into e to the power u to the power e to the power u, that means e to the power 2u, correct? So from here you may write e to the power 2u cos square v plus e to the power 2u sin square v. So e to the power 2u is common, cos square v plus sin square v plus cos square v, already you know it is 1. So ultimately it is coming e to the power 2u. So therefore del of x y z by del of u v is equals to e to the power 2u. That is the answer. Clear? I think now it is clear to everyone. Okay, so now I'm going to solve another question from here. It is also very interesting and important also. So if u is equals to x plus y by 1 minus xy and v is equals to tan inverse x plus tan inverse y, then find this. So it's very easy. So please write down here u is equals to x plus y by 1 minus xy and v is equals to tan inverse x plus tan inverse y. So therefore del uv by del xy is equals to determinant del u del x del u del y del v del x del v del y. So these are the four unknown you have, correct? So we need to calculate separately del u. Here I'm writing on the right side of your copy in this slide, but during exam time you need to write line by line. Okay, it will be better if I can write as per exam time. Okay, exam copy. So these are the unknown, so please write down. Therefore what is u? U is equals to x plus y by 1 minus xy. So we need to calculate del u del x. So that is 1 minus xy whole square, that is 1 minus xy whole into derivative of del x of x plus y minus x plus y del x of 1 minus xy. So ultimately it is coming 1 minus xy whole square. So it is coming 1, that is 1 minus xy minus x plus y, it is coming minus y. So ultimately it is coming 1 minus xy plus xy plus y square by 1 minus xy whole square. Ultimately it is coming 1 plus y square by 1 minus xy whole square. Clear? So this is your del u del x. Same way you can calculate del u del y. So it will be xy whole square, 1 minus xy del y, x plus y minus x plus y, del y of 1 minus xy. Okay, so from here you may write 1 minus xy, there is del y is 0, there is 1 minus x plus y into minus x by 1 minus xy whole square. So ultimately it is coming, if I simplify, it is coming 1 minus xy plus xy minus x square plus x square by 1 minus xy whole square. Ultimately it is coming 1 plus x square by 1 xy, that is whole square. So now you know del u del x, del u del y. Okay, so another part you need to calculate, that is your, therefore uh, v is equals to tan inverse x plus tan inverse y. So del v del x equals to 1 by 1 plus x square is equals to plus 0, that is 1 by 1 plus x square. Okay, and del v del y is equals to 0 plus 1 by 1 plus y square, that is 1 by 1 plus y square. Okay, so therefore you may write down del of uv by del xy is equals to del u del x, del u del y, del v del x, del v del y. Basically it is coming del u del x. What is your del u del x? Is coming 1 plus y square, 1 plus y square by 1 minus xy whole square. It is coming 1 plus x square by 1 minus xy whole square, and it is coming 1 plus x square and 1 plus y square. So if you cross multiply, basically it is coming, this cancel, 1 by 1 minus xy whole square minus this into this, these are cancel. So it is coming 1 by 1 minus xy whole square. So ultimately this minus this as a 0. So this is the solution of, these are the example from Jacobian. This is a very simple process. If you have a 3 variables, then same way we need to calculate 3 variables wise. That is a 3 determinant, third order determinant you need to simplify. Okay, thank you very much.